Hi there, and congratulations! If you're watching this, that means you hadn't fallen asleep watching the first part of this guide, or just YouTube autoplay kicked in, and now it's time for part number 2. In this video, as I promised before, I will try to repair this R9 for ATP, but as I said before, this board is a junk box material, so manage your expectations. Chances for this repair being successful are slim to none. And there is no way in hell I would try to repair this card if not for making this video. So let's jump right into it. First, I would like to say a couple of words about the tools that you will need for this diagnostic procedure. I mean, of course, you need everything. You need soldering irons, hot air stations, microscopes, oscilloscope,
a few moments later.
VGA workstation, good audio system and pole dancers. Okay, maybe not the last one. But because in this video we will basically be more concentrating towards the diagnostic procedure, I mean you can do a lot with only the multimeter. So, what else? Well, it's always a good idea to not make things worse than they already are. So repairing these video cards, or any other appliances for that matter, with real power supplies and this board plugged into PCI Express slot of a motherboard is not a very bright idea. And it's also not very convenient, as you can see. I must be this tall in order to see what I'm doing or measuring here, and chances for me shorting some component is very high. I mean, in theory, you can also work under your car without the jack, but usually it's what gets you in hospital. So to solve this problem, there is a thing called PCI Express riser. I remember when I was shopping for those, dude at the counter didn't understand what the hell I would want to buy, and then he kinda realized and said, "Oh, you're talking about that thing that miners use?" So yeah, it's kinda that thing that Bitcoin miners use. But we're not gonna mine anything with it. What we are gonna do is just plug our card into this PCI Express slot and plug other part into our motherboard. That way we have perfect access to all the components and it's very easy to work on this board. This riser also needs 12 volts supply for it. So you want to hook it to any supply that is capable of providing 12 volts and it has current limiting capability. What I'm talking here is called lab power supplies. They are essential piece of kit you want to have when working on these boards. One reason being, as I said before, you don't want to burn any holes on this board because your normal PC power supply is really capable of burning holes in this board. And second reason being that you can monitor the current that is used by this board. And they're not very expensive. I bought this Tomens DC power supply model ATM 305 for, I don't know, 45 bucks. That's with shipping. And you know what the best part is? It's working. So again, you know, no reason to not have one. It has a voltage adjustment, it has a current limiting capability, and I mean, you know, the real world performance is not so bad after all. When maxed out at 150 watts, it has something like 40 millivolts of noise on its outputs. And you will also need something to connect this PCI Express riser to your lab power supply. So this is something that I mocked up in 5 minutes or so. It has two PCI Express connectors that you connect to your VGA card, and it also has one SATA power connector. And on the other end, it has two banana plugs for your lab power supply. Okay, I connected this VGA card to my lab power supply. Let's turn it on. And let's set the current limiting for something like 2 amps. Okay, so now if we short our power supply, the maximum it will draw is 2 amps. And that's a really big difference between this power supply and real PC power supply that is capable of producing 800 watts. That's what, like 26-30 amps? With 26 amps you can start welding a metal or making a hole here in a PCB or opening that GPU. So again, use current limiting. Okay, let's enable our lab power supply output and see what happens. And we have a current of 0.4 amps. That's really sad current. What it tells me is that we are stuck somewhere in our power-up sequencing, so let's see where exactly we're at. So let's turn our multimeter and see what voltages do we have on board here. So I already suspect that there is no VDD-GFX. Yep, 0 on all phases. And now VDD-PCIE also. No, 0.95 it seems. Yep. Let's flip the board and check MVDD. Nope. VDD-CI. Nope. What's next? Next is our 1.8 volts. Right here. Yep, 1.8 is present. And that's about it. Of course, 5 volts will be here also. 3.8. That's interesting. It should be 5. Oh yeah, sorry. I was measuring on the set pin. Yeah, so we have 5 volts also. That is fed directly from 12 volt power supply of PCI Express. So it seems that we have 1.8 enable signal formed in this area here. And we have the signal on pin 2 here. Yep, it's present. And we have our 1.8 volts. But we are not going any further than that. Do we have power OK on pin 1? We don't have power OK on pin 1. That's strange. Do we have a short on our power OK line? Let's check that. Nope. All okay there. So it seems that something is pulling our power OK pin number 1 to ground, and by something I mean one of those transistors here in this power sequencing area. So I hope that I would not have to do this, but it seems like I have to figure out what's going on there exactly. So let me draw a schematic and get back to you. So this is what I was able to figure out. My first assumptions about the power-up sequencing was not entirely right. As you can see, our 1.8 volt power good signal is actually responsible for generating 0.95 enable and VDD-GFX-C enable signals. But that's because someone at XFX decided to not stuff one transistor on this board and make it 1 cent cheaper. I bet he got promotion for that. But just so you know, that is not a standard way to do things. VDD-GFX-C enable should only be generated on board when 0.95 volts is there. And it was the case on this board only if this Q1024 was here on this board. But as you can see, it's no stuff. Anyway, that's not important now. what is important now is for us to figure out why is our 1.8V power good signal is pulled to the ground. So let's turn our power supply, our multimeter, and check what's going on Q1020 base. So as you can see, all those transistors are marked 1 AM. The best guess Google has is that it's MMBT3904 NPN transistors, which kind of makes sense. So, okay, let's find our Q1020. There it is. I have one of my probes on the ground and second probe. So it should be emitter, base, and collector. Let's check. Yep, this is ground. What do we have on the base? We have 0 volts on the base. So this transistor is closed. Yep, and we have 3 volts at its collector. So Q1020 is closed, and Q1021 base is pulled up by that 10K resistor to 12 volts, and it's open, and thus we don't have 0.95V enabled signal. Okay, let's see what is pulling our Q1020 base to ground. So we have our Q1020 base connected to Q210 collector, and my best guess is that this Q210 is responsible for CTF circuit, that's critical temperature fault, but I really have no way to tell you for sure. So this is our Q210, and let's see what's going on there. So base emitter collector, let's see. Yep, we have 0.65 volts on the base, so it's open, and thus pulling the Q1020 base to ground, just as I expected. Okay, at this point I'm really not interested why it's open, what's happening, is there any fault or not. My only interest is to go down the power sequencing steps and see what voltages do we have on board. So what I would do now is remove this resistor that goes to base of our Q210 and basically just disable it. Okay, let's see, did it help or not? Ooh, okay, it looks like we have VDD GFX. So, I put a heatsink on this GPU to not burn it more than it already is, probably. Anyhow, let's check what voltages do we have now. By the power consumption, I can see that we probably have them all, but let's make sure. So let's turn our power supply and let's check. So, do we have 0.95? Yes, we do. Do we have VDDC? Yes, we do. Do we have main core voltage? Yep. Okay, let me flip that board. What's next? Next is our, I think this is VDDCI. Yep, 1 volt. And our 1.5 MVDD. Great. It seems everything is here. So, what's next? We have all our voltages on board. Should we hook it up to motherboard? Well, no. There's plenty wrong with this board, and let's get back under the microscope. I will show you. Okay, so I think you saw this area in my previous video. It looks kinda bad, but actually most of those tracks are not broken, except maybe this one and also probably this one. So that's 2 tracks to fix and we're ready to go. Okay, what's next? Next we have one missing capacitor here. But again, as I mentioned in previous videos, most of those caps are for NVDD decoupling. So let's check if this is the case also here. Yep, NVDD. So this is not critical because all those caps are in parallel, and one or two missing won't prevent this card from booting up. Here again we have a couple missing components under the RAM chip. Again, let's check if those are the NVDD caps. Yes, they are. Okay, let's go to the next one. Here again we have missing NVDD cap. And in this area we're obviously missing this component. It got whacked out of here at some point in time. And we also have some flux residue. What that tells me is that someone probably borrowed one of those two components, because you can plainly see that those two components are basically the mirror copy of those two, and at least one of them is present here. So this one should be present here also. Let's see where this track leads us. It's going straight to DVI connector. And if I look to DVI connector pinout, I will find out that this pin is named HPD. HPD stands for hot plug detection. So basically it works like that when you have your PC working and you disconnect and connect another monitor. This pin will sense that and your monitor will be detected. So again, in theory, we don't need that because we have one DVI connector that has all the components they need. And also when card boots, it will automatically search all the ports for edit lines and will read the display information if it finds one. So let's forget about this one for now. And here's the thing that really troubles me. As you can see, someone did something in this area too, and we probably are missing component U100. Why I'm saying this scares me a little bit is because this pin is named PRST, and if you watch my previous video, you will know that PRST stands for Platform Reset Signal made by Motherboard Hub. It's basically a global reset signal that has to somehow go to our GPU in order for it to have a proper reset. So if this pin is hanging here in the breeze like it is now, there is no way we will have our GPU to boot. So I really have to think about this one. Okay, so I done some thinking off the camera, so you would not have to wait and hear me mumbling, and basically this is what I was able to figure out. As I said before, on most of the boards, this PRST signal is buffered by some logic element, and usually this element is a tiny logic AND gate, and if that was the case on this board, then it basically all checks out. As you can see on this pinout, here we would have a VCC for our tiny logic that would be 3.3 volts, and yes, it's a 3.3 volts. And here we would have to have ground. Yep. So here's our two input signals and this is our output. And this all kind of makes sense because on other boards this element unstuffed too, but basically what this does is connects our incoming PRST signal to the output of buffer. So it becomes unbuffered, but PRST still goes further to the board. So I think what I will do for now is just put a, 1K resistor here, and we'll go from here. If board won't post, then we will inspect it further and really place NCP08 here. So here you can see we had a major disaster. that led to those PCI Express data lines coupling caps missing, and actually I think maybe a couple of those lines even broken. I'll have to measure that. That's a very common problem on these boards. It's very easy to knock off one of those little buggers out of there when plugging in the card or doing something else. And if even one of them are missing, it will definitely prevent this card from booting. So we'll have to put those back and maybe repair one or two of these tracks. And here we have last battlefield area on this board, and we have two components missing. Well, actually I'm not sure about this one, but this one is definitely missing. So this area scares me a little bit too, because it's kinda very near the GPU, and it has a lot of resistors concentrated here. So again, my experience tells me that this could be straps for, I don't know, memory settings or something like that, because again, all of those resistors have kind of non-standard resistances, like this one here, 2.56 kilo ohms and 1.666 here, 2.44, 2.2, well, 2.2 is standard. Well, you get the idea. And they all are connected as dividers between 1.8 volts and the ground. Yeah, so basically what they're doing, they're dividing the voltage to some particular level, and then this voltage, you have test pads here, then this voltage goes to the GPU. So yeah, something tricky is going on in this area, and I'll have to do more thinking.
2 very boring minutes later.
Okay, so I done some digging of the camera, and it seems that I was right. These are really straps for something. Hard to say for what exactly, but most of the time these are used to set the type of memory, memory timings, type of BIOS, etc, etc. So the good news is that we're missing not two components that I thought before, but one, because these are connected in parallel, and I think this is a mirror of these two, one cap and one resistor, just to form an RC circuit. But what exactly is this value of resistor here or here? I was not able to figure this out. So let's measure what is this resistor's value. It's 4.5 kilo ohms. Okay, so best I can think of is to put here something like 4.6 kilo ohms, make it a equal divider. But yeah, our chances for fixing this board went from slim to astronomically low. But hey, we went so far, so let's fix all the problems that I showed you before, and we'll go from there. Okay, so I got this card connected to my test rig, and well, let's see what happens. And we have a B2 code, and there is no video. Well, I mean, that's pretty much what I expected. So let's dig deeper. Okay, so let's see what is happening with our PRST signal. Let's measure it after the resistor that I installed previously. Okay. Our PRST is going high, so that means that nothing is pulling it down and GPU should be properly reset. But let's install our logic element here that would buffer this reset signal, because maybe the timing is not exactly right, maybe something else is wrong. So if we want to cross this area from our list, then better do it right. So I have finished replacing this tiny logic AND gate, and I was going again through all of those PCI Express line caps, and one of them looked kinda suspicious to me, this guy here. So I decided to measure. And what do you know? We have a shorted cap here. So another tip for you all. If you have physical damage near those caps, or one of them is missing, always check the other ones because they might be shorted. Okay, so I took that AND gate from a donor board and put it here. I also changed a couple of those PCI Express line caps, but that shouldn't change anything because we're using PCI Express riser here, so basically it's limited to PCI Express 1 mode, and that mode uses only the first pair of PCI Express lines. Okay, so let's see if that changed anything. Let's turn our power supply, the motherboard. I think it's booting longer now. 99, that's okay. Oop. Nah, same B2. Okay, let's see, do we have a reset? Reset after our buffer here. Yep. Reset is high, so our tiny logic is doing its stuff. Okay, I think we can put a cross on this area and let's go to our suspected strap area. I put a 5K resistor there and I have no idea is it right value or not. So I think what I will do now is put a pot here or variable resistor, and I'll remember my young days and, you know, just try all the values that I can think of. Okay, let's do that. Okay, so I put potentiometer there and try stepping the strap voltage every 50 millivolts or so. As you can see here, I can adjust it quite well. But as you might probably guess, well, it didn't make any difference whatsoever. We still have B2 postcode. B2 is very general postcode. If you're wondering what that means, it basically means that motherboard BIOS is trying to load option ROMs from all the other devices and list them in post screen at least. But something is not going right when it attempts to read this option ROM from this VGA board. I mean, it doesn't explicitly says that VGA board is bad. It could be, I don't know, RAID controller or other board. It's just that when I disconnect this VGA board, this B2 is gone, and that way I know that VGA card is the one that causes this code. So if you have B2 code and cannot post, it doesn't necessarily mean that it's a VGA card that is causing this, just so that you know. I also thought that it's kind of strange that there are missing resistors in that strap area, but I was able to find some high-res photos online, and it seems that it's normal on these boards. But yeah, I mean, I don't really get why would you just put their resistors hanging in there. Well, whatever. I also used help from the audience card here. I just called one of my acquaintances and asked maybe if he had this kind of R9 board. And he had one donor board like that. I just asked him to measure that resistor, and it's a 5K. So let's put a 5K resistor there, and we can cross-check that out also. So now I think we have good straps, we have proper set on board, and yeah, there is not much left to check. What I will do now is I will check BIOS if that is alive and if board reads it, and if it's all okay there, I will maybe try to find a working one and flash it, see if that helps, do some more poking and measuring, and I will get back to you. Okay, let's find out, does our GPU reads BIOS or not? So, let's see what's happening on pin number 1. That's chip enable. I have a scope in roll mode, so we won't miss anything. Alright, we have first initialization. And there is read. Okay. Let's see what's going on SO. Power on and read. Okay. SIO. Init read and S clock. Alright, so all signals are there. So now it makes sense to take that BIOS chip off this board, put it on my programmer and flash a new BIOS and see if that changes anything. So let's do that. Okay, and we're back to the bench with our new BIOS, and let's see how that goes. And I already see, yeah, we got the same B2. Well, by now this gets really frustrating and yeah, not much left to do for me here. It seems that our GPU went to a better place and is pretty dead at this point. Okay, let's do a quick experiment. I will put my hot air station at something like 220 degrees and let's heat it. It will not reflow it because lead-free solder melting point is something like 230 degrees, so we're not reflowing it, we're just heating, and usually that is enough to temporarily revive it somehow, miraculously. So let's do this trick and see, maybe we're lucky. Okay, our board has cooled down and let's see if we can fix boards just by heating the GPU. And it seems no, not today. Okay, so it seems we have a really sick puppy here. I already checked that we have 27 MHz crystal running off the camera. I already checked all the PCI Express lines, they are all there. Check the DVI lines, all there. Yeah. So it's not much left for me to do except call this board officially dead. So the next logical step would be to replace the GPU itself, but of course it's not feasible. This is already an old card and I have no use for it, so investing in a new GPU just doesn't make any sense for me. But since I already wasted so much time on this board, I think what I can do is to reball this existing GPU. I mean, there's always that 1% chance that we had some board flexing somewhere and we had that broken magical track somewhere underneath the GPU. Of course it's a possibility, but in my practice this happens, well, basically never. So I think it so happens that I have stencil for this GPU. So yeah, let's go all the way and reball it. What the heck. And we are under the microscope and looking at the PCB beneath the GPU, and yeah, as you can see there are No broken tracks. Soldering mask is not of the greatest quality on this one, so yeah, we have some areas that I will have to touch up a little bit. But all in all, it looks pretty normal to me. So no lag here also. Okay, let me fix that soldering mask, reball the GPU, solder it back in place, and I will meet you back at the bench for the final turn on. Okay, and we're back at our bench. I did some cleaning on the GPU area. Not that it helps, but it's always nice to have a clean board in front of you. Okay, so let's see if I wasted a couple more hours or did we made any difference this time. So let's turn our power supply on and all attention to the motherboard. And I think I will run out of sad music when editing this video. We still have a B2. Okay, this is official. This GPU is really dead. Oh, and by the way, you see the current climbing. That's normal because I didn't put any heatsink. But who cares, right? It's already dead. So now I can say that I really did my best and try to make this a successful repair, but not all repairs are like that. I'm 99.9% sure that if we put a new GPU here, it will work just fine. Okay guys, I hope you find this video entertaining or at least informative. And from my side, I promise I will try to make more videos with a little happier endings. So take care and hope to see you in the next one.